time to rewrite. It says find the derivative using definition of derivative, then rewrite the function using an exponent and find the derivative using the power rule to see if you get the same solution. So definition of derivative, one more time. If we wanted to find the derivative for all x values, right, we want to find the limit as h approaches 0 of f of x plus h minus f of x all over h, right? That instantaneous rate of change as we move h on the curve closer and closer and closer to that one specific point in question. So if I want to take f of x plus h, that means that I'm going to plug x plus h into this original function, right? So I'm going to have 1 over x plus h. And then minus f of x is just minus 1 over x, right? So I'm subtracting off the function, and then I still have all over h in the denominator. So I want to simplify this a little bit so I can take the limit as h approaches 0. Right now I can't plug in 0 because of the denominator. So a good first move might be combining these two fractions in the numerator by using a common denominator, right? So the common denominator is going to have to be x plus h times x, because they each have a different factor. So this is a good, just remember how to simplify rational expressions. I would have to multiply by x plus h over x plus h for this fraction, and times x over x for this fraction, so that I have a common denominator of x times x plus h. So let's see, what do I get in the numerator? Here I get just x. Here I get a negative x and a negative h. Do you see that when I distribute the negative sign? Because it's 1 times all that stuff. So the x minus the x term adds up to 0, right? So my new numerator is just a negative h. Are you with me on simplifying that numerator? I still have h over 1 in the denominator. So I'm just writing it as h over 1 because when you divide by a fraction, that's the same as multiplying by the reciprocal of the fraction. So I can sweep this up here to the numerator, and it's really like multiplying by the reciprocal 1 over h, because I don't want to have a fraction divided by another fraction. So I can take this fraction in the denominator and bring it up here, multiply by the reciprocal instead, and what's going to magically happen? Now I have my h over h able to cancel in the numerator. So it looks like I have negative 1 left in the numerator and x times x plus h left in the denominator. So if I'm taking the limit as h approaches 0, what am I left with as my derivative? Negative 1 over just x squared, right? Because this is a 0 right here. Negative 1 over x squared. That's what it's telling me my derivative is. I ran out of room to do the power rule on this piece of paper, but it said now try the power rule for that same function and just verify that they came out the same. So to do the power rule, I need to write this with just an exponent instead of as a fraction. So isn't this equal to x to the negative first power by the negative exponent rule? Well, what would the power rule have you do? The power rule would have you bring the negative 1 down as a coefficient, and it would have you decrease the exponent by a power of 1. So isn't that the same as what I just got? I got negative 1 x to the negative second power. Isn't that exactly what this was equivalent to? Negative 1 x to the negative second power, right? Because a negative exponent is just, I could flip it and put it into the denominator and make it a positive exponent. So isn't that cool? So we proved by the definition of derivative with some tricky algebra that yes, the power rule also works for negative exponents. So that's not a formal proof, but it's kind of justifying that it came out the same for you. So the last one I wanted to do was, hey, let's do it with a radical and see what happens. So it says find the derivative using definition of derivative, then rewrite the function with an exponent to use the power rule. So let's do this one last time. Definition of derivative. I want to do f of x plus h minus f of x all over h as h approaches 0. So we are going to plug in x plus h under this radical x. So I'm going to have the square root of x plus h minus the square root of just x all over h. All right, can't plug in 0. Can you remember any strategies that we used when we had radicals in our limits that we could try? Begins with a C. Not substitution, not factoring. What approach did we use when we had a radical in our limit? Conjugate. Was limits that long ago that you forget? Right? Aren't you seeing some of the strategies from limits right in this unit? Right? We need the strategies on how to simplify limits to get to our derivative. So if I've got a radical, I can't do any factoring or canceling right now, but a strategy to get rid of radicals in your problem is to use that idea of multiplying by the conjugate binomial. So I need to change this negative sign to a positive sign, but leave everything else the same. You will have some limits on your final exam. So you need to know these strategies, even if I'm not asking you the derivatives. These are still helping you review some of those limit rules that we should know. I am multiplying the top and the bottom by the same thing so that it's like multiplying by 1. What happens when you multiply a radical times the same radical is that the radicals cancel each other out. So I just get x plus h as my first term when I do FOIL, right? You see that? So I'm starting to write my answer down here. I've got x plus h as my first term. What happens nicely with my outer and my inner is that they're opposite, right? I have positive radical times radical, and I have negative same radical times radical, which adds up to 0. Then I've got my last term, negative radical x, radical x. So isn't that just minus x? So my new numerator, thanks to the conjugate, is just h. See that magic? I have h in the numerator. I have this h in the denominator, and I'm not going to touch this other binomial yet. So don't distribute. See how I still have this h and this binomial? I'm trying to take the limit as h goes to 0. So canceling that out is perfect because now, can't I plug in 0 and get my final solution? What do I get? I get 1 over 2 radical x's. Do you see how this is a radical x plus another radical x? 1 apple plus another apple is 2 apples. They're telling me that this is my derivative by the definition of derivative. So let's see if we can prove that using the power rule that they come out the same. Are you with me on that part? So let's go back. How do I rewrite the square root of x as a fractional exponent? Good review of exponents. 1/2, right? So x to the 1/2 power by the power rule for the derivative would be what? Bring the exponent down front. So I'd have 1/2 x, and I have to subtract 1 from the exponent power. So that would be the negative 1/2 power, right? Because 1/2 minus 1 is negative 1/2. So is that what I just got in the other problem? Let's rewrite this so that it looks the same. I would have 1 over 2x to the 1/2 power, right? All I did first step was move this guy into the denominator. Isn't that 1 over 2 radical x? That's what I got, right? 1 over 2 radical x and 1 over 2 radical x. So yep, the power rule works not only for polynomials, but for fractional exponents and negative exponents. So it's a nice rule. It applies to a ton of functions that you've learned. So I'd like you to take a couple minutes and try to simplify the back number 5 through 8 problems. Now on some of these, before you apply the power rule, you're going to have to do a little simplifying. So for example, on number 5, before you do the power rule, you might have to change this to a fractional exponent. You might have to change this to a negative exponent. So you don't want to do it with fractions in the problem or radicals in the problem. And like on number 6, before you start doing the derivative, you're going to have to distribute the t to the 3/2 to all 3 terms. So before you start, and like on number 7, your first step would be dividing each term by t to the 4th. Let's do number 7 together first, just so you can figure out how to approach some of these problems. So I need to first split up number 7 into 3 separate terms. So if I have t squared over t to the 4th, what would that simplify to? Not the derivative, just can't I take this 2 and subtract the 4 and write it as t to the negative 2nd power? Right? I'm doing division using my exponent rules. I actually want my negative exponents now to do the power rule. I don't want fractions. What about t cubed over t to the 4th? That's going to be t to the negative 1st power, right? Because 3 minus 4. And then minus, I've got 1 over t to the 4th. So that would be minus t to the negative 4th power. So see how I have 3 separate terms now that each have an exponent? So you apply the power rule to this step. So see what you can do on 5, 6, 7, and 8 for just a couple minutes, and we'll go over them together. A lot of exponent rules being practiced.